Yo. Can you guys hear me okay? I think I've finally got my stuff sorted. Yeah. Okay. All good. Welcome everyone. It's been an interesting week, has it not? I hope everyone out there is doing all right. Bit of a crazy time to be alive. World's a pretty insane place at the moment. I'm sure that a bunch of the nerds out there are saying to themselves, "This is what I've been trained for," you know, solitude. Yeah. So you know, I hope you're all okay, and all the people that you know and love are okay. We're in for a particularly trying time, I think, over the next few months. So look after each other. Keep in touch with people that you care about. Make sure everyone's okay. You know, the usual stuff. Don't be a dick to people. Be good. Be a good human. But yeah. Greetings. Dean, Serializing, Atwolf, Splat, Consolitis, Archbishop, Tom K. It's great to see you all. Thanks for jumping on. T. Did you bring your brews? I had the same brew as last week. Liam. I will call you Liam. Thank you. Welcome, Liam. It's good to have you on stream, mate. Kettle is on. So I have Dong Ding Oolong again. I enjoyed it last week, but boy, I tell you what, by the time I finished drinking it, I was sweating. It's pretty warm in here, so I might have to drink it a little bit slower. But yeah, make sure you got your brews on. And there's no dark chocolate for me. I'm going to be a good boy tonight. As tempting as it is to go and raid the back fridge to grab another bar out, I'm going to be a good boy. Plus, I've only just finished eating dinner and it's a bit early, I think. So, anyway, you know, I was pondering what to do this time, and I do need to get back into the Maturp development, but as you can see directly above my head, I've decided to do another Pico stream. And so I think the reason for that is the last time we did it, you know, there was a pretty good response. A lot of people had fun. I had a lot of fun. And doing the CTF streams doesn't come without any prerequisite knowledge, whereas the Maturp stuff clearly does. And a lot of people probably haven't gone through all 30 of the previous episodes of that. And so I'm guessing that the viewership will come down. I'm thinking what I'm going to do is do the Maturp dev stuff over a weekend or sort of during the day, and bash that out and spend a little bit more time on that than the 2-hour time boxing, because the next thing we're going to get to do is substantial. That's channel support. So I'm going to probably stick to this kind of thing in the evenings. If you have any other suggestions, then feel free to let me know. Anyway, so part 8 of I don't know how many. Let's change the arrangement of the screens. There we go. Is that better? There we go. You should be able to see where we left off. Now, the last thing that we did, I believe, was this Echo Back binary exploitation challenge, which was actually a bit of fun in the end. And so what have we got left? We've got some general skills, more forensics, more binary exploitation, a bit more reversing, more binary exploitation, a web exploit, more web, more binary reverse. So we've still got quite a few more to get through. So maybe we should just kick straight into this script me challenge. Can you understand the language and answer the questions to retrieve the flag? So I'm guessing we're going to NC to this thing, and we're going to have to sort of respond in kind to a set of questions. So let's have a squiz. We can exit out of all this cabins. Whoops. And let me just exit out of this. Exit. Okay. Well, let's see what it says. Ooh. Isn't this interesting? Yeah, the music's not too bad. Hey, this is similar playlist to the one that I think I had last time. Alright, so I wonder if these rules remain the same. It does look very lispy. Death by parentheses. But no, it's not. Okay, so you plus absorb right. That looks interesting. Let's start with a warm-up. What happens when you combine this and this? Do you get 3, 4, 5? Correct. Okay, so this is like a... It's not Lisp, it looks like it's just a horrible parsing exercise. It's interesting, looking at the rules, some of them aren't particularly obvious. Combine, absorb, left, combine, absorb, right. Okay, yeah, I see. Okay, now we're cooking. So we end up with... I would assume that plus whatever that is to the left. So is that another 3? 1, 2, 3. Yeah, it is. All right, see if you can get this one. Yuck. It's pretty gross, isn't it? Because I think at the end of the day, what it looks like you can do is sort of flatten the lists as you go. This basically goes inside this one. So we'll end up with this, followed by whatever was on the inside, followed by whatever's on the inside of this. And then this. Is it really this simple though? That's not correct. What did I get wrong? Yeah. Nah, this is just made up. It's just absolute made up nonsense, I would say. I don't think there's any particular language. So the rules are the same every time. Are the questions the same every time? No, they're not. Okay, so that would be... Yeah. The question is, I mean, the associative rules or the absorb rules are pretty standard. Ah, here we go. It's the combine, absorb, absorb, combine, right? Combine, absorb. So it depends on... So that one. Ah, I see where I went wrong. So this is going to be... And then 1, 2, 3, followed by another one. No. How close was I? I had one too many, didn't I? Oh no, I didn't have enough. Ah, so it just took this and actually shoved it inside there. Which is kind of, okay. It's a bit confusing, isn't it, eh? 2 screenfuls of parentheses, yeah, I know. I get the feeling that this is just going to get continually more painful. So... I'm not a fan of these kind of challenges. Ah, see, I mucked that up as well. So we've got to figure out which rule is being applied. Is this the order that these rules apply? Because it's quite easy to go, well, that should just be... That'd be this rule here, right? Except for the fact that that's nested even more. This just seems kind of boring. And you're unable to solve them manually in useful time. Yeah, so I basically have to write a parser that would pull these apart and, you know, based on these rules, reduce them to the smallest possible set and spit them back out. So we can continue going down this path, or we can do a different one. I've got a couple of indications from people that they don't really want to see this, so do you want me to carry on and try and solve this, or should we move on to something else? Cast your votes. I could do this off stream and just walk you through the solution. 1 vote for skip. 2 votes for skip. 3 votes for skip. No one's saying don't skip. Okay, so what I'll do then, we'll give this one a miss, and I'll go and solve that one maybe off stream, and I can just walk you through the solution. What do you reckon? Or at least my solution, which could be terrible. But yeah, I've got to admit, it's not particularly appealing. Here we go. This is another pull an image apart to find a flag. Not a fan. So I guess we're back to binary exploitation. Is everyone happy with that? I assume you are, given how much you guys love the binary exploitation thing last time. Get root. Are you root? You get no checks. Did you get? Let's pull the source down and copy a link for location. Okay. Oops. Manual page still open. No check. Savage. Okay, let's have a look at what this thing is. It'll be another C thing. 64-bit this time. Now let's have a look at the source. Let's see what we've got. Is that still a reasonable enough size for you guys? I assume that it is, given that nobody is complaining at me just yet. Righto. Let's start at main. What's main doing? Might even full screen this for now. Okay, so we've got a buffer on the stack, pointer to what looks to be an argument level, and a pointer to a structure which is defined here. The structure contains a name and an enumeration of a level. So it does the usual shenanigans of removing buffering, so things get spat out immediately. And then what do we have here? We have show your current user and authorization level, log in, set auth, set your authorization level, must be below 5, get flag, print the flag, requires root basically. Reset, log out and reset authorization level, and quit. Okay. So I wonder if we're actually going to have to do some real binary trickery here, or whether we'll be able to abuse a logic bug. Given this in binary, I assume that there is going to be some kind of memory-related trickiness. Plus, it's always appealing to see things like this. Okay, what do we got? So we show the menu, and then we loop. We say enter the command, pull in 512 characters. Now, it's probably worth diving into some documentation here just briefly. So fgetS. Let's open a few references. Make sure that we get all the information that we need. Okay, so reads at most count -1 characters from the given string and stores them in the character array pointed to by string. Parsing stops if a new line character is found, in which case str will contain the new line character. Or if end of file occurs. If bytes are read, no errors, writes a null character at the position immediately after the character written. Okay. So, in this scenario, fgetS will write to buffer 512 -1 characters and null terminate it. Liam, this is i3 window manager. Been using this for a while now on recommendation of my good friend Justin Stephen, and I love it. It's fantastic. Yeah, it's great, hey. Okay, so we read in 512 minus 1, right? I've read that correctly. Reads at most count minus 1. So fgetS count, we're specifying 512, so we can't really override anything based on that. And if it receives a new line, obviously it stops. So it's reading up to 511 characters from standard in and null terminating for us. So if we give it show, now this is interesting, it's only comparing the first 4 characters. So it's doing an strn compare, each one of these. So we get the show command, the login command. And what does login do? Ooh. Oh, this is interesting. I might even rearrange the source a little bit to make it a little easier to read because the indenting is not right. So let's just fix this up a little bit so that it's nicer to read. Do love me a bit dim. Okay. Righto, so show just spits something out. Now this could technically be used as a memory leak with the assumption that we have somehow managed to control the user structure and point this somewhere we control, which could be interesting, depending on what it is that we're trying to do. What does login do? So str tokenize, string tokenize says start at a particular location in memory and keep going until you find a particular character. Which is interesting based on our understanding of fgetS. Parsing stops if a new line character is found, in which case it will contain that new line character. Or if an end of line, oh hang on. If an end of file occurs, if bytes are at a, no errors occur, writes, and if no errors occur, writes a character at the position immediately after the last character written. Yeah, okay. So if we put a new line in right at 512, that's going to be, yeah, I'm getting ahead of myself. Anyway, so this is looking for new lines, and if it doesn't find it, then it says that it's invalid, which is interesting, right? So where are we at? It then allocates a user structure from the heap. Duplicates arg. Now this is interesting, right? What is arg pointing at? So this is going to see how arg points at wherever that new line character is and it duplicates it. So I would assume that when we log in, we end up with the new line being included. We should have to play with that and see. We've got a set auth command, which does something similar. And here we're converting whatever we give it to a string level. Ooh. If level is greater than 5, level can only be set to authorization level below 5. Ah, I wonder if we've got like an overflow issue here, although string to unsigned long, I assume that's what that is. So if it's signed, hang on a sec, is level signed or unsigned? Level is, I'm going to say it's an integer because I believe enums are integers. So that's interesting. We will see. Anyway, we will see. Righto, so where did I get to? Sorry. Get flag, we have to make sure that we have level 5. Yep, enums and C assigned ends. Yeah, that's what I thought. Thank you, serializing. And then we've got a reset, and then we've got a free. Ooh, this is interesting. 3. Else, invalid option. Put S menu. Alright, so this is one of those cases where things look fairly innocuous. Give flag is obviously not interesting to us. I believe that the purpose would be to corrupt something somewhere along the line that's going to allow us to modify a few pointers, or allow us to sort of trick the system into thinking that, you know, the content of the user buffer is pointed somewhere else or something along those lines. But we will see. It's definitely, this one looks like fun. Anyone have any thoughts to begin with? I'm getting notifications. I should turn all my stuff off to the side, shouldn't I? Initial thoughts. Anyone have any ideas based on what we're seeing here? Which time zone? Aussies. Oh, sorry. There's an address from PM at 9 PM. Oh, yeah. That'll be in 10 minutes. Standard is not strict. It's a good rule of thumb as majority assignments. That's 6 in STR talk things off by 1. Well, I think the reason for that is they're assuming that there's going to be a space immediately after. So let's see, we've got 5 characters plus a space becomes 6 characters. Yeah. So are you root? Okay, so we are going to be NCing to an endpoint. Yeah. Hey, Multi! How's it going? What's news, Multi? Oh, I've got news for you guys. Tomorrow night, Multi is going to be streaming for Sec Talks Melbourne. So if you're looking for a stream to watch tomorrow, I believe it's going to be on the YouTubes, like all the cool kids are using. And Rickster's here as well. How you going, Rickster? Thanks for coming in, man. Rick gets to hang with me pretty much all day. So I'm surprised that he's coming in at this point as well. I would try first to overflow the level, see if the condition that checks. Yeah, I'm going to try that for sure to begin with. I'm also thinking that that may well be a little too obvious for a, what is it? How many points is this? 550 point challenge. So it should technically be harder than the previous one, right? Liam's locked in his house until the 30th of April. So all streams of quality are appreciated. Well, I said Multi was streaming. I didn't say it was going to be quality. Sorry, Multi. I'm being cheap. But there should be some good talks. Ah, you're in Hawaii. Yeah, cool. All right, so let's have a think. What are we going to do? We should just play with the thing a bit, shouldn't we? Let's do that. Yeah, let's do that. Let's see what it does. I'll admit that by staring at the source right now, not exactly sure what the issue could be. But anyway, let's have a squiz. So if we go show, we get not logged in. So if we log in, Multi is a legend. Alright, so STR Talk should basically say go to the next token. That's right, it goes to the next token after the new line. Or up to and including the new line. Okay, so yeah, okay, that makes a bit more sense. So we start basically and we tokenize up to the new line. I think that actually, does that at this point overwrite this somehow? Or it's got some internal state behind the scenes, doesn't it? I can't remember. But given this is not multi-thread, it's not that big a deal anyway. So if we look at who we are, we're logged in as Multi as a legend. Ooh, what is this? What is that again? Oh, user level. Okay. Righto. So we should be able to then change our command. Set. Excuse me. Set auth And we then give it, what, an integer. So we should be able to say 1 and show. Okay, set auth for show. Set auth. This is where, like, 5 being root is like, nope, you're not allowed. Set auth minus, oops. Set auth minus 1. Can only set authorization level below 5. Okay. So there is some overflow style shenanigans going on here, because when we specify -1, str, let's just look at the documentation for strOUL. strO2UL. str, yeah. C++, all the same. Alright, I'll make this a bit bigger. Parses the C string, interpreting its content as an integral number of the specified base, which is returned as a value of type unsigned long int. Right. Okay, so it's an unsigned long int, but then it's immediately truncated to a signed integer, which means that if it's unsigned, it'll be truncated to a signed integer as well. So we don't really have the means to overflow or underflow. So, not entirely surprising, hey, serializing. Hey, Liam, that's the story of our lives, right? Google until you find the answer. Okay, so let's have a squiz. What else can we do? What else can we do? Obviously, calling get flag. It's not going to work. And reset gives us nothing. Pro level Googling on site without the client noticing. That's so true, Dean. It's so true. Love it. Alright, so one thing that's interesting about this is that when we reset, we free this thing here, right? So we've got the ability to free something, but the username is set via what? String dupe. Okay, so my immediate thought here is, given how we don't really have the ability to pass in any more characters to do some kind of overflow here, right? That's not, even if we did, we would maybe poke this pointer, but this pointer here only gets used after it's set by the code itself. It's not like it's used anywhere else. Let me just check that. Okay, so sorry. So it gets set here on line 79 and then used. Gets set here on 100 and then used. And that's it. So even if we were able to overflow one character, which we can't, we'd be modifying this pointer, which then gets overwritten by something we can't do anyway. Oh, you use GoBuster. That's awesome. I hope that you found it very useful. Faraz. If the username is allocated right next to the auth level on the heap, then you can potentially overflow into the auth level after the free. Okay. Yeah, so we do have, we've got the user that's allocated on the heap, and then immediately after that, if the name is duplicated, that'll be on the heap after the fact. So we might be able to overflow from the user to the name, assuming that we could do that, but not the name over to the user. Would that be fair? So we'll debug this in a second. We'll see where things live. Just to see if that makes sense. Okay. Maybe we should just do that. Hang on a second. Okay. So the only thing we free is the username, but we don't actually free the user even though we malloc the user. So that implies that technically we've got a memory leak. And that by leak I don't mean disclose. I mean leak as in if we continually log in and log out, log in and log out, then we constantly leak the size of struct user. I've got an idea. Okay. So if we allocate a user and then we give them the name and the name is specified, right? Then if we log out, then we free up the username, which means this space is now freed. If we then log back in again, this area of memory that we did have our username in that becomes the area that the next allocation for the user. Does that make sense? Sorry, I'm not explaining particularly well. So malloc will allocate things linearly, right? I assume. And then, so if we have a user structure of a certain size, followed by the name because we've duplicated that string, we then free that up, we allocate a new user at the exact same spot that that string was, then the contents of this user structure should contain what we had in the string previously, because malloc doesn't like scrub memory when it returns it, right? Yeah? Let's do some debugging. No one's talking, so I'm going to assume that you know what I'm talking about. And if you don't know what I'm talking about, it's your fault. Now is your chance to speak out. Yeah, sure thing. I seem to, it's kind of hard to find those perfect levels, but sometimes the music is a little higher as well. So let me wind it back to about there, serializing. Is that any better? Hopefully that'll be a bit better. If you need me to wind it back a little bit more, please let me know. Yep, cool. Okay, sweet. Thank you for that. Yes. No, you're welcome. You're not setting the level to a default value. No, I'm not. So here's what I'm thinking, right? So if we run, I'm going to log in. And I'm just going to give it a bunch of A's. Oh, yeah. Okay, so actually, what am I doing? Disassemble main. What I want to do is I want to break at the point that malloc is called. Where are we? Inputs. Tokenize malloc. Okay, so let's break here and continue. Okay, so if I show, that's who we are signed in as. Okay, now if I reset and then we go login as bees. Okay, so let's just see what happens here. When we call malloc, I would assume that the value that was in the user to begin with, which I assume is in this, given that we're storing it straight away. Let's have a look. X 16 WX RBP crikey. Just want to see what's in there. Okay, so here we go. This is where the user is stored, right? So the user has a pointer. Is it QX? No. GX? There we go. Okay, so this pointer should point to the start of... Hang on, is it that? Oh, this is a stack pointer, isn't it? Let me just check the code again. Yeah, so when we call malloc, there it is. So user is a stack pointer. So that's where it's going to go. Is that right? FFDE6. It's like it's offset to here. Yeah, right, okay. According to the code, at least that might be the way to go about it. Yeah. The auth level remains uninitialized, yeah. Okay, so I'm just going to skip over that call. Now in RAX, we have, I assume this is a heap pointer, 603720. 603, there you go, heap pointer. So if we just do the same dump for racks, what have we got in here? What is that? That's just an arbitrary value, isn't it? Can you see where I'm going with my thought process, by the way? I think I'm missing something. Okay, let me run that again. So when we go log in, and I'm just going to put 4 A's this time. What I want to see is the structure or the layout of the stack. So after this call and setting, we should see the user pointer at this location, right? Okay, so there's the pointer that was allocated. And then if we go and do the same thing for that pointer value, it's all blank. Okay. Now afterwards, after it's done that, we've allocated the user, and now we're calling string duplicate, and that pointer is going to be moved into the first part of this, right? So we've got the user. So we need the first 8 bytes of the user structure, which is in here, should be overwritten with whatever's currently in RAX, which is that value there. Yeah. So that would be, okay. Here we go. All right. So the user pointer points to 6D0, which is here, and there's our string, right? Yeah. Okay, so that makes sense. And we've duplicated the string, so you can see that that's there, right? And now this is the thing that's going to be freed. I would assume that this is like the metadata that's associated with the 21 bytes sort of thing. Now, what I'm going to do, I'm just going to set the auth level. Set, what was it? Is it set auth? Set auth. Actually, before I do that, let's just disass main again, because set auth results in a call to strou, whatever it is. So what I want to do is just watch what's going on when that happens. Here it is here. I think we're on the right path, to be honest. So if we go set or 4. Okay, that's going to return 4 in racks. Yep. And then it's going to shove that in the user pointer, which is in... Is it here? Hang on, we haven't done it yet, have we? So after that, we've got to... Oh, it hasn't done it yet. Yep, so next... Okay, should have done it now, yeah? There it is. So our user level is 4. So there's the pointer to the name, which points down here. And then there's 4, which is our current user level. Yeah. Okay. So then, if we continue, and then if I go log in B, and... Oh, I've got to reset. Login B. Okay, so we have freed up our previous string. Now, before we do anything, let's have a quick squiz at memory. So B0, that still points at D0. Which looks like it's been cleared. I was under the impression there's no code in here. See, I was kind of expecting to see this stuff here. I was expecting to see this here still. Does that make sense? Yeah, I know what you were saying there, Faraz. And I'm on the same page as you totally. What I'm saying is that when we do the username next time, we want to just make it really long, right up to the point where it sets the first byte of the auth level, which is basically we write eight characters, and the 9th character we write is like a hex 05. The problem I've got is that I was expecting to see this memory stay the same, and it doesn't look like it is. It's like something else is going. Oh, hang on. See, I don't even know. That looks like a pointer, doesn't it? It's like it's been clobbered already. So malloc is going to return 6D0. So if we went back here, see D0, that's exactly what I expected it to do. But I didn't expect this stuff to be cleared. If we do B0 minus 8. Yeah, so there you go. There's the size. First value, second value. Or I should say, there's probably, I think there's metadata. But what I'm just confused because I was expecting the A's to still be here. So show will just show me the B's. So the thing, I'm a little bit, bearing in mind I'm running on a fully patched Fedora system, and I'm wondering if free clears the memory out. So let's just cancel, right? This main. So in our call to free, I'm gonna break here. Okay, so let's rerun. Let's log in with A's, just 4 A's. Actually, we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9 A's. Okay. And It's still the same spot, so we can just reuse our memory dumping doohickey. Righto. Let's just do the string jeeping thingy. Okay. Now here's what I'm going with, right? So see how we've got our 8 A's followed by a 9th A, right? And we know that this pointer here is the pointer to this string, and immediately after that is the auth level. So what I was thinking was we write 4 1s, and then instead of another 4 1 here, we write 5, and we end up with an auth level of 5, right? And then we reset and relog in with a any username, and the structure that we get allocated appears in the same area of memory that we controlled before, and then this character here is already set to the auth level. Do you know what I mean? Ladies and gentlemen, we are in the presence of greatness. Manifestation has just appeared for the first time ever on my stream. Welcome, Matt. It is lovely to have you, sir. How are you doing? Snuck in without me noticing you. So yeah, Matt Graber, everyone. We should all be flattered with this man's presence. Stoked to have you on stream, mate. We're just working through another CTF challenge, a binary one. All good fun. And you've just arrived. We are. We're in the presence of graveness. Well said, Dean. Okay, so the user structure itself is 20 bytes. What happens if you make sure the user knows? I don't think that's the problem. I think the problem right now is the freeing, right? So if we go like this and we reset, we break on the free. Have a look at this. This looks fine now. I reckon after the free, it's going to be cleared. Could be wrong. It's cleared. Okay, so freeing is killing me on my machine. So you know what that means? I'm going to have to speculate and just throw it at the target. So let's just do that. Let's fly blind, people. Okay, so let's just touch exploit.py, chmod plus exploit.py. You're going to have to forgive me because I could have just royally muffed this up. User bin and Python 2 because reasons. Import pwn. Okay, so we're just going to go straight to the remote, and I'm pretty confident that this is how it works. So this is what we need on this port. Do you have faith? Do you all have faith in me? I hope you do. Pwn.remote. Yeah, I don't know, man. I'm calling. I'm calling it. I'm gonna call it. I'm calling it now. Okay, so we're gonna go p.send. We're gonna send line, and we're gonna log in with we're going to send a bunch of A's, so we're going to send 8 of them, and we need to send in a 5 auth level, right? Then we'll go p.recv until what is it? We've got an angle bracket, and then actually we should probably do that first, right? And then we're going to go send line. We're just going to reset. Oh, there is a random beep. It's because... Hang on just a minute. Let me see if I can kill... There we go. It's coming out of VMware in Vim for some reason. It's a recent change. And I've just muted VMware, so hopefully you won't hear it anymore. And I won't hear it anymore. Yeah, sorry about that, Apple. Okay, so we want to do that, and then we just want to reset, right? So we'll send reset. And then we want to log in again. But this time, I mean, it doesn't matter what we do. Yeah? And then once we've done that, let's just go show. And then we'll go p.interactive. Let's just see what this does. Let me just confirm my logic. So we go 8 and then we only overwrite the 9th byte with auth level 5. Oh, look at that. Look at that. Boom. Yeah. I love it when a plan comes together. Does that make sense? I'm pretty sure that it's the latest version of the libc free on my machine that was killing me, and that was a bit of a stab in the dark. But yeah, you got my train of thought on that, yeah? Ask Justin to do another one. So it's be very important to know maybe in future. Actually, let's have a look at what the hints said. If the program used calloc to zero out the memory, okay, there you go. So, or used an updated version of a particular operating system which does that magic for you. Any questions about that? No? That was quite fun, wasn't it? Can you find the flag using the follow? We're just going to do a reversing one now. We'll just move straight on to the reversing one. That's very long. Oh dear. Make directory assembly 4. No check certificate. Alright. Keep going in here. All right, so I'm gonna keep that. That was a decent win. Just go reversing assembly. All right. Oh Jesus. This looks pretty gross. Compile and run. Kind of defeats the purpose though, doesn't it? Hey, I feel kind of cheaty when I do that. Hang on, how big is it? 45%, really? This really is revolting. Extended restrictions for midnight tomorrow. What are we facing at Wolf? What are they saying? It's just pinging at night, and I think my missus is letting me know behind the scenes as well. Nope, she's definitely quiet. Not that the non-Australians particularly interested. Morrison says the government, we will work night and day to ensure that we can get more capacity into your Centrelink system. This reflects the size and need, the size of the need and the size of that need. Excellent. Hamled. Yeah, I do get the feeling that each one of these is just almost a randomly generated label. Oh, there's uppercase and lowercase. That makes it horrible. Okay, so each one of these is so 82 in man ASCII. Hang on. All right, so if we look at say capital R in decimal, that's 82, and that's 82. Capital S 83. So each one of these things is literally just grabbing what would effectively be the ASCII value of that character label. LB though, 91. Left bracket. BS backslash right bracket. CT is caret. So all of those labels is just a fancy way of converting to ASCII. Yeah? What's FF00? Oh, it's just 0. Don't know what RCB is. Where are we? Decimal 125. Curly brace. Right curly brace, left curly brace. Interesting. It does smell of rock, doesn't it? It's like it's deliberately given gadgets or something, but given it's a reversing thing, it's clearly something else. You know, things like this stand out as interesting, don't they? Okay. Alright, so when we get to main, what do we do? Doing some stack alignment shenanigans. Assisting registers, creating some stack space, pushing some hard-coded values on the stack, and then calling sub. I don't want to go through and compile this. What does sub do? This is messy, isn't it? Yum installing Kubernetes. That's pretty funny. That is pretty funny. So what are we thinking? Do we want to tediously go through the reversing process of this? What are you thinking? The Hamlet, they're definitely labels. I'm not sure what the global word actually means in this context though. My NASM isn't particularly great. Maybe it's just saying that you don't need to, maybe it's just somehow marking each one of these things as some kind of sub/function, and that's it. Yeah, but you see, if we look at each one of these, it's not like they're actually referenced directly. Oops. You know what I mean? Hey Eric, welcome sir. Wow, weddings limited to 5, funerals limited to 10. Oh, I've just had someone just follow. Who is Jake Beinler has just followed, and Lucas Farias as well, which started following earlier. Sorry I missed that, but thank you both for the follows, very kind. Great to have you guys on stream. So my current feeling on this reversing one is that it's not going to be particularly entertaining for me to fumble through this live on stream in a way that looks like it's fairly repetitive. And I feel like automating this in some ways is cheaty. Am I missing something? Thinking maybe those large values being moved in encoded form. Yeah, so that sub that we were looking at before, Like this value here, is that hard coded somewhere else? Yeah, look, it's used. And that value is used in a few spots. And it's used by the looks of it as a base for a multiplier. Yeah, I don't know. I'm going to skip it. I've made the executive decision. We're going to skip it. And I might dive into that again a little bit off stream. And if it's something that I think would work well on stream, then maybe we'll come back to it on stream. But it doesn't look like one that's a great deal of fun to dive through. Am I wrong? Yeah, I think that's just one of those long and drawn out things. It's probably above my pay grade as well. So let's just move on. Yeah, makes sense. Cool, okay. Well, no one's complaining, and people went strangely quiet as soon as we started diving into that, so I'm guessing they're not particularly entertained by it themselves. Either that or they're currently listening to our Prime Minister talk about how the country's being locked down even more. So I will move on and let's try this GPS challenge. Territory GPS. Similar story, we get the source, we get the binary. Copy link. I'll grab the source as well. Oh, fat fingering tonight. Hey Multi, are you still there, man? Greetings, Ben. How are you, sir? Thanks for returning and joining in. Binary GPS. Okay. Let's have a quick squeeze. This doesn't look like a massive file, does it? Hopefully this isn't going to be one of those things that relies on a really weak or vulnerable version of libc. Yeah, mate, doing fine. You know, as good as we can be given the current state of play and how crazy the world happens to be at the moment. But you know, we're the fortunate ones, right? We get to tinker with computers as a job, which means for those people who aren't used to working at home, the transition isn't that hard. And for those of us like me who have somehow been lucky enough to work from home for 10 years, it's business as usual. Hey, business as usual. Finally managed to catch a stream. Hello, QMCPZKS. Whoa, we've got anonymous gifter back. Okay. Now, I know that there have been at least 2 separate anonymous gifters, and I know who they are. One of them did admit it to me. The other one has not admitted it to me. So I have no idea who this is. Yeah, someone's being cheeky. Multi will be upset that he's been gifted a sub. Yeah. So, oh, it's B-Man. B-Man, weren't you one of those surprising anonymous gift subby people? Huh? Was it you? Hands up, come on. No. Liam, yeah, that's probably the only logical conclusion we can come to, right? It was the troll gods. Courtesy of COVID-19. Well, thank you for the subs, whoever anonymous gifter happens to be. You gotta stop doing that. But it was very kind of you, and I appreciate the support. I'm sure the crew who's watching appreciates the support as well. Okay. Let's have a squiz at what's going on here. So again, in main, set buffering to nothing, so things get spat out straight away. And then, now this is cute. Cute and ugly. Hang on, let's see what this says. So this is a 64-bit binary. Let's have a quick GDB. Check sec. Canary enable fortify NX Pi. Okay, so what's clear here is that on any particular operating system, with ASLR on the stack, the address of buffer is going to be randomized, and so they're using the address of buffer as a random seed to srand, random seed, which is interesting. And then after that, we initialize, acquire satellites. We need to access flag.text. Current position is query position. What's your plan? fgetS buffer, size of buffer. So that's doing the same as you. So I don't think we're going to get an overflow. Not that we've got anything particularly interesting to overflow into, except for maybe this location. Where do we start? Ah, okay. We get to specify this location. This is cute. We actually get to give it an address. And then it calls what we give it directly. How interesting. Oh! I know what's going on here. QMCPZKS. Can you give me a 1-minute summary of this EP, what this episode is about? Okay, yep, cool, man. We've already played around with one binary exploitation challenge. We've finished that, looked at a reversing challenge and decided to bail on that because it doesn't look like something that's particularly entertaining from a streaming point of view. So now we're looking at another binary exploitation challenge where we have been given the binary, which we were looking at just over here, and we have the source of the binary at the same time. And our job obviously is to try and figure out exactly how we can exploit this in order to get access to the flag. Every single one of these streams gets archived and shoved on Vimeo and YouTube, as Dean has very kindly just said. And so even if you don't get to play along now, you can review them at another time. But yeah, right now I think we're probably going to spend another sort of at least half an hour playing around with this binary exploitation challenge. But straight away, I'm pretty sure I have a vague idea of how we might be able to get something out of this. Yeah, so $P is an address. So scanf $P says give me an address, and the address format would be something like OXFF7 blah blah blah. That's the kind of format that it would be in, because that's what gets spat out, I believe. Yeah, I'm pretty sure, but we'll play with it and we'll see. But this is interesting, right? Because we don't have any PIE. So we know that all of this code is going to be in the same spot every single time. Now, what's fascinating about this is that I think the aim here is to try and figure out, or at least reduce what we know to be random down to a set of arguably predictable things, but in a reverse direction. So this acquiring satellites, you see how it says GPS initializing, and then it just waits and prints a bunch of dots, which is just weak sourced. It then says acquire satellites. Now you'll notice that random, this is interesting, right? Rand returns a value between 0 and int max, and that's modded by 10. And then each time that happens, it sleeps a certain period of time and prints a dot. Right? And so what it's actually doing behind the scenes is it's waiting a random period of time. Yeah? So then after that, it says we need to access the flag. Our current position is query position. And that again uses rand. It uses this leet GPS accuracy. It just comes up with basically a number of some kind. What is this doing? Query position returns a value on the stack plus this random offset. Okay, this return value will actually give us a stack pointer, right? And that stack pointer we should be able to use as some kind of offset to figure out where this is. Okay, and then once we've got this, we should be able to do some kind of calculation to say, our buffer's here, and we know where that buffer is. And then here it says, where do we start? We actually give it the pointer, which it stores in this location variable, which is actually a function pointer, and then it calls it. All right, so I'm just going to run it, and I'll show you what this will do. It's going to take us friggin' long period of time. Okay, so current position is blah. What's your plan? So if I type in 41, 41, 41, 41, 41, 41, 41, 41, what does it do? Oh, hang on. Oh, no, that's right. That's what we want. Why did it do that again? I wanted it to crash. There are two inputs. Oh yeah, what's your plan? I'm an idiot. Okay, so the buffer is just a bunch of shit. X. Thank you. Who is that that pointed that out? Yeah, that was Hamlet again. Thanks for that. Okay, so Rax is what we've just given it, and you can see it crashes because clearly that's not legit. So what we need to be able to do is take what it's given us and infer the location of this so that we can specify it here and actually execute our code. And I would assume that the stack's executable, right? So where's the stack? Yeah, here we go. Sorry, that's not the right one. Stack. Stack is read write X. So yeah, basically that's the story. So when we get this value out, when we get this, we need to access the flag. Our current position is blah. You can see that we basically get a value on the stack 1337, and that is, we get a value between 0 and 1337, and we subtract half of it. Without PIE, the stack is in the same location every time. No, it's not. It's ASLR'd. But what is clear is that we do have the ability to go sort of within the realms of reality with regards to where this buffer is. Okay, so let me just explain what I mean. So if we have a look at main, buffer is what gets passed into the srand call, yeah? So srand is just here, okay? So I'm gonna break here, and we're gonna run it, okay? So we call this, an EDI I believe is the pointer. So RDI, I assume because that's on the, is that on the stack? Pretty sure that's on the stack. Before I continue, disable dissas main, or just dissas main again. Now we know that further down here when we call printf and then fgetS, so fgets is just here. We're going to break here as well. And I want to see the value that was in here. All right, so RDI points to this buffer. I'm pretty sure that that's the story, right? So if we look at XS of that address, oh, that's standard in. Oh yeah, of course. So not RDI. I did RDX and RDI is what I wanted. Excess of that is blank string. So if we go over that and we give it those, okay, so that's where our stack buffer is stored. And so when we get to the result of this call to, where is it? We're in a query position. All right, let's run this again. We'll ignore the ran call for now. Hey, Ricky33, how's it going? From Rax, who's based on IVP. Yeah, exactly. So that's stack pointer stuff, Hamlet, for sure. Okay, so query position is going to return in Rax this value here. Okay, I'm just going to chuck it in a... Actually, I won't chuck it in a comment. I'll just put it raw so we can actually see it. So that is query position. And then when we continue to... Where are we at? fgetS, which is... So this is where the stack, where our actual buffer is. Okay, and you can see how close together these things are. Now, this stack buffer is hex 1,000 characters. Whereas, yeah, it will be because GDB removes ASLR, but in production, it won't be that way. Yeah. So what we want to do is we basically just want to get to a point where we can say, oh, I know for sure that we're going to we're going to be able to give this program a set of input and then give it a pointer that we know is going to land somewhere in our buffer that's kind of randomized. So this GPS accuracy, as we said, is leet. So we're going to get a number between 0 and 1337, and we're going to subtract half of 1337. So if we went, for example, max range is basically just this. Okay, 29C in hex. So that's the max range, which is a significant, significantly smaller value than this. Right? Now, what I'm going to do just quickly, let's discuss query position. So as we can see from the code, we've got this STK. That there is added to this offset at the end, right? So we're looking for an add at this location here. Add RAX and RDX. So I would assume that this value here, RDX, is the exact stack buffer location. So let's run this again. Okay, so we're going through our process of initializing GBS. Now you'll see we call query position, and here RDX is clearly a stack buffer pointer, and RAX, that is not a stack buffer. It's a value. It's a negative value. So you can see we're actually moving further away, right? So what I really want to know at this point is that we've got query position here. Buffer. I'm just going to say, what was it called? STK. Okay. So STK at this point is this value in RDX, which is this value here, right? Now if we continue, get S of the stuff in RDI, just make sure this is correct. Yeah. Yeah, there we go. So the stack buffer is definitely the same. So these are the two things that we're interested in, right? Now, what we do know is that the maximum distance between this value and this value will be, give or take, 1337. Right? So we're going to get a value that's somewhere between 1337 on 2 and minus 1337 on 2. Okay? So that means that when we get our stack buffer, all we need to do is figure out, we can figure out right now the distance between these two. Okay, let's do that now. So if we go print, we get buffer, and we subtract this stack location, you can see that it's 35 bytes apart. Okay, so the difference is hex 35, right? That's how far apart they are. But the value that we get returning query position can be minus 1337 on 2. We've already done a print for that, haven't we? Where is it? X29C. To plus. Okay? So what we want to make sure that we do is we need to add 1337 onto the value to force, 1337 on 2 to force it into the positives, and then have a NOP sled after that, right? So if we were to do this in Python, we would basically have we read in query position equals whatever was given by the program. Then we go, we've got the difference between buffer and STK, which we know would be the absolute perfect offset, right? So that's what we would need to add to query position. But query position maybe forward hex 29C bytes or back hex 29C bytes. So what we need to do is we need to change our address so that we pass in a value that we know is going to be well and truly in our buffer, and pass the initial state regardless of what that random value is. Okay, so that basically means we need to have a buffer that is, let's say hex 29D bytes of NOPs, right? And then when we specify this location, we can just say query position. So whatever it is that we got, we want to add the difference between those two plus hex 29C. And that's going to land in our buffer. And then when we give it the payload, when we first give it the payload in, what is it called here? When it says, what's your plan? So it's not payload really, it's plan. Plan will be whatever this value is. Right? No, sorry, that's supposed to be location. Right? But the plan, when we give it the plan, we're going to give it a bunch of NOPs. So NOP characters times by 0x29D. Okay? So that should mean, hang on, it's not 29D, it's leet 1337. So that means in the case where, and then after that, we would have our payload. So that means if we specify that in our buffer and we provide this calculation as the location, if the location is back 29C bytes, we add 1337 and we end up 29C bytes into this plan, which lands in the NOP sled, and then we can go. If it's at the other end of the scale, we basically get directly to the end of this NOP sled and run the payload directly. And so that little bit of entropy that we get in here is effectively moot. It doesn't have any meaning anymore. Does that make sense? So, with that in mind, let me cancel this for a sec. And I'm going to copy. Where was it? What was the one we did just now? It wasn't authenticate, was it? It was RU root. Let's copy that here and we'll edit this and we'll just deal with this for now. Right, I'm just, let's leave that there. Okay, so this is going to be opponent process. Now, what is it called? GPS. Now, again, I'm not going to go through the process of automating GDB. We'll just do it in a manual fashion because I don't think this is going to take that long. But let's take this stuff here out of the source and stick it in here. All right. Now, I'm going to leave these two values as they are. I'll give them some meaning though. And what was the name of this? GPS accuracy. So we'll do the same thing here. Accuracy equals 1337. So we'll actually do the calculations of this stuff on the fly. Okay. All right, so when we run this thing again, what do we do? It says GPS initializing, so we just sit there and let it do its apparent randomization. And then we're going to go p.recv until, where are we at? Have I lost everyone? Everyone's super quiet. Okay. And then we're going to end up with our stack pointer. Following along, excellent. So what we're going to say is position equals recv line. It'll be p.recv line dot strip. And then we're going to unpack that basically as an integer, right? So we know that that's an integer at base 16. So then we can say print current position is, and then maybe we'll just go OX. I'm going to sneeze. And because we know that it's a, is it a, yeah, we want 16x. Yeah, 16x. Format pods. Now let's just comment that out for now. We can get rid of that. Why are you complaining? Invalid syntax. Yeah, I don't care. Okay, so let's see what this does. Getting lunch ready. Good lad. Did that not do what I wanted? Oh, that's why. And I should be running exploit anyway. Okay. Current position is this. In fact, what I will do is get rid of the zeros because that's probably extraneous and unnecessary. So we've got our current position. And then from there we can say that our location is going to be pos plus buffer address minus STK address plus I'm going to force this to be an integer. And this is going to be GPS accuracy on 2. Right, so that's going to be our location. Location will be format location. Let's just see what that looks like. So this means that we're going to be, man. Why am I seeing... I'll just get rid of that 16. It's confusing me. There we go. So we knew the current position was this. We've calculated that the offset should be here. And then what we're going to do is we are going to have a payload is going to be all of the NOPs, which is a total amount of times GPS accuracy. And then after that, we're going to be adding a payload, which should be, for now, we're just going to leave it as a breakpoint. Yeah. Okay. So once that's done, we read up to p.recv until plan, and then we're going to go p.sendLine payload. And then let's just do this again. And then we're going to go p.recv until... Actually, we don't even need this, do we? We need... Yeah, we do the same again. Okay, and then we go p.sendLine. What are we going to do? OX 0x dot format of location. Now at this point, what we might do is do the whole attaching thing. So let's just go here. Let's go raw input attach. All right, so we go exploit. It's doing its thing. Okay, so we attach. We can go gdb ppid of GPS. Cool. So what we want to do at the point that the fgetS is called, we've got printf, and then there's a scanf. So let's break here. Okay, we've attached. What happened there? What did I do wrong? Oh, I know what I did wrong. p.interactive. Super important. (9707). We've got ASLR here, don't we? Scanf, is that the same? Yeah, I think it is. Ooh, here we go. That's better. Okay, so according to this, Rax points to exactly what we've given it, and look, it's in the middle of our NOP sled. So if we continue to run, we've just hit our payload. Cool, huh? So now what we need to do is just put like a 64-bit reverse shell, which I can never remember how to do. Sorry, binsh is what we want to do. So let's go. We'll use Pwn Tools to do it. Pwn Tools, assemble exec binsh. I know that there are thousands of examples of this. Shellcraft, yep. Tutorial, let's have a squiz. There's going to be something here. Here we go. Look at this. Beautiful. This is the kind of thing that we want. And I know that there is submodules. There's got to be examples here. basic examples. Canned assembly. Shellcraft.sh. Shellcraft module gives you pre-canned assembly. It's generally customizable. Easy way to find out is to look at the documentation there. Help on the function, execute NSH. So this is exactly what we're looking for, right? But we need to somehow set the architecture for Shellcraft. So we're going to be using AMD 64. Listen, yeah, so this is basically what we need, is to use find peer, nope, fork exit get peer, it's just .sh, right? sh, here we go. Look at that, that's what we want. Look at that, it's perfect. That's what we want. So, if we go back over here. Yeah, exactly. They have all this magic stuff baked in. It's beautiful. So what we should do when we're generating a payload is... And where was that other thing just before? Asm shellcraft.nop. I think I'll just leave the nops hard-coded, actually. It might be a little bit of code reuse overkill. Alright, so this is what we want. So we can go... that's what we want. Now, I'm sure there's options, or there's going to be things like invalid characters. Yeah, exactly. So we'll get rid of this, get rid of this. That's pretty much all we needed, is that example, right? But I'm going to leave that in there as a helper. It's pretty much all I want. There must be some way of specifying like bad characters or something at some point, but we won't worry about that for now. Let's just see what happens when we... Yeah. Oh, yeah. Whoops. ASCII codec can't decode byte 90. Positional 9 range. Really? Hang on a second. Okay, so it does do it okay. That's fine. Why would that be a problem? It's Python 2, it shouldn't matter. Is that fair to say? Shouldn't matter. Let's do this. You reckon this will work? Yeah, Python 2, that's why I choose Python 2, because usually this tends not to be a problem. Let's just see what this does. Payload. What have I... Really? I'm so dumb. Yeah, right. Hmm? Right. Bit strange. Ah, I've already killed it. How did I kill it? Was there something in here that was an invalid character? Probably that extra send line. No. I'm clearly doing something stupid. Shellcode ends in a new line. Yeah, thank you. It took me a while to figure that out, didn't it? Okay, so it's definitely the shellcode. Adding the shellcode payload at the end is causing some issues. Here for the tea and tunes, albeit late to the party. Welcome, Binchuk. It's good to see your face again, my friend. Hope all is well down south. Another local Aussie. The Binchuk is probably a bit of a giveaway. Alright, so what is it about this shellcraft payload? Actually, you know what I'm going to do? Ah, I know what's going on. Watch this. It's text. I need to assemble it. I'm such an idiot. Okay, so how do I assemble this? I know, everyone should laugh at me. That's how bad I am. Okay, so asm. Pwn.asm. See, you guys come here, think I know stuff, and I clearly don't. That's pretty funny, isn't it? Let's be fair. That's pretty funny. I wonder if... Do I need to specify an architecture? I guess not. Oof. Yeah. I think I do need to specify... We're all learning something here, right? Asm... Yeah, that's exactly right, Hamlet. That's exactly what it was. So, I need to somehow specify the architecture for the ASM. Pwn tools ASM AMD 64. Okay, so this is what I just found. Finally, ASM is used to assemble shellcode provided by Pwn tools in the shellcraft module. Yep, that's good. That's what we want. So assemble code, invoke ASM. on the code. Arch, there we go. There it is there, Arch, AMD, OS Linux. So this is basically all I need to add. Thank you, PointTools. There. There we go. Good times, folks. Are we actually going to get a breakpoint? There it is. Boom. That's what we want. All right, so let's get rid of this. I think we all learned something there, didn't we? Shells. There we go. So that does work. Now we just need to point it at the remote, which is this one. Assuming that everything that we're doing here makes sense, of course. E equals phone.remote. Do you reckon it'll be this simple? Come on. Yay! Cat flag.text. There we go. Winning. Did that make sense? That's quite fun, wasn't it? I quite like that one. I mean, to be honest, I don't think that was worth 550 points. I think, you know, the knowledge of Malcolm Free is probably slightly harder, but I think the 550 points for that is probably a bit rich. I really appreciate the example of how to exploit Dev more competently with GDB enhancement point. Yeah, man. You know what I'm going to do, Hamlet, is I am going to, probably on a future stream in the not too distant future, is dive into PointTools specifically. So we'll just get a shitty ROP challenge from somewhere, and we will automate all of the things with PointTools, including GDB and adding breakpoints, which I've done before, but I just haven't really been keeping my scripts up to date. So it'd be good to do that on stream and have everyone see how you can use PointTools to automate the invocation of GDB, adding breakpoints and all of that sort of stuff. There's a lot of stuff in there that's really cool. So where are we at? That was another couple of challenges down, and we are approaching the 2-hour mark, and I did promise myself that I was going to stop at the 2-hour mark today. So, because I tell you what, the other day it was only 3 hours and 10 minutes, but man, it bakes me. I must be getting too old for this stuff. You know how it goes. Does anyone have any questions on any of the stuff that we've covered? I know it's like we're coming up to 2 hours, which is why I'm not going to start the next challenge. And what we'll probably do is we'll just come straight in next time and jump into this Flask card skeleton key thing, assuming that the web thing is still up. We'll just work through these web exploitation challenges and see what we can come up with. And no doubt I'll probably have to rely on you folks a lot more for that sort of stuff, because I feel super out of touch with these web exploitation CTF style challenges. So I'll be learning from you more than you guys will be learning from me. But yeah, if you've got any, the last one was long, hey. But if you've got any questions, please ask, and if you don't have them now, you can hit me up on Discord, you can hit me up on Twitter, whatever works. But yeah, I think that's pretty much it. I don't really have anything more valuable to add, but we've got 10 minutes, so I can sit here and talk meaninglessly for the next 10 minutes, or I can answer your questions, or we can end it. It's up to you. Given that everyone's so quiet, clearly distracted with the awesomeness that's coming out of Scott Morrison's mouth right now. It's probably what it is. Although that talk is probably truly over and done with now. But yeah, Multi. Oh, hey. Yeah, gotta go to bed. Multi, while you're here, dude, do you want to share a link to your YouTube thing for tomorrow? So people, all the folks know where to go and what to do. So as I said earlier in the stream, Multi's going to be streaming Sec Talks, Melbourne Talks on YouTube tomorrow. So if you guys are looking for another stream to hang out on and chat and listen to some talks, then I highly recommend that that you do that. Multi, come on, answer me, dude. Links. People want links. There we go. Link in the chat over there. So yeah, jump on that. There, I don't know what the talks are, but it should be fun. Really good to hang out with people. And I think it's because of COVID and everything. Everyone's going to be remote. It's going to be streamed and whatnot. So get in on that because that'll be good. But look, thanks to everyone for coming on stream. Thanks for the suggestions. Thanks for the good chat. Thanks. It's good to see some new names. And Hamlet, it was good to have you involved in the discussion and asking the questions and offering insights and whatnot along the way. A little more quieter in the chat than usual. I don't know whether that's because of me or because of the challenge or because people were distracted, you know, trying not to cough all over their relatives. But hey, who knows? All right. Thanks very much. Much love to all. Be safe. Make sure that you're constantly washing your hands. Stop touching your face because from what I can tell from the videos that I've been watching with these medical professionals over in the US, they say pretty much all of the contractions of COVID are when you're touching a surface that's got the infection and then you touch your face. So wash your hands, stop touching your face, stop touching each other, keep your distance, much love, and be good to each other.